closer look on what is TCP retransmission, how it happens. So I'll explain this topology, what I did exactly here, no big thing. So I got a router here, I got a switch, both are layer 3. So I can assign an IP address to it. So this is just a PC for testing. So what I did, I have configured the IP details. I'll show you. Pretty simple, just a point-to-point connection. I assigned an IP address as 10.0.0.2 10.0.0.2 on fast Ethernet 0/0 here. I assigned this IP address 10.0.0.2 and fast Ethernet 0/0. If I go to Ethernet switch 1, show IP interface brief. So I assigned 10.0.0.1 on fast Ethernet 0/0. So this is a point-to-point connection. Point-to-point connection between source and destination. So I have to check the basic testing. So can I ping 10.0.0.1? 10.0.0.1. Yes, I can ping. This is my loopback 10.0.0.1. What is my IP here? Show IP interface brief. Again Ethernet switch and 10.0.0.2. From here, let me ping 10.0.0.2. Nothing much, same the default CIDR value I have used. Same subnet mask, CIDR 255.0.0.0/8. And I have created an ACL. What is that? Show IP access list. So here I created, whenever I see FIN packet, log this information in the ACL. And we can see that in Wireshark. So all other traffic is permitted. If you're not permitting this, this is a default deny. So you have to permit TCP and you have to allow your IP traffic. Only then your IP communication happens. So that's it about the ACL, very simple. So I want to log the traffic for FIN packet. That's the objective of this lab. And along with that, we'll see in the same lab how this retransmission happens and how it happens and what is the sequence number and how it recovers from it. So this is all about the config here. And if I go to PC1, here I created a gateway here. I created a gateway, show IP interface brief to check a connection here. 30.0.0.1 fast Ethernet 0/1. So the gateway is configured as 30.0.0.1 here. So this PC is .3, 30.0.0.3. Can go to this PC. I'll show you what is this. You can give a question mark and you can see the commands what you can run. If I give show IP, so it says okay 30.0.0.3 and /8 and my gateway is 30.0.0.1. And this is a MAC address and this is a default MTU 1500 bytes. So this is all the simple config I got here. So from here I can ping 30.0.0.1. I'm just trying to check all my basic connections are good. Yeah, I get ICMP response back. So my connection is good. So now let's generate some traffic. So now I am on router 1. and I enabled telnet because it uses TCP. Show run include VTY. Should. Okay, so let me give show run. Okay, so line VTY 024. So total 5 connections and the password is Cisco. This is the config I have with Ethernet switch 1. So from this router, I'm trying to establish a connection, telnet connection, and it is using a TCP. Let's see what happens. So let me stop the capture. So I'm establishing a connection from this device to this switch, and I am using telnet. Right. So let me open up this putty session, and I'm going to do telnet 10.0.0.1. So before that, let me start the capture here. Start capture from fast Ethernet 0/0 to fast Ethernet 0/0 on Ethernet switch to the router. Let me close all this. Start Wireshark. Okay, say it says port ID 0/0. Okay, fine. Now let's go back to the router 1. And now I'm trying to establish a telnet connection. Telnet 10.0.0.1. And if I give a password, Cisco, enable Cisco, I did that. So now I exit a connection. I exit from the source. I'm done. Now stop the capture. If you actually see here from the beginning, so it says acknowledgement 11. So I send an acknowledgement on packet number 11. I send an acknowledgement and it is a duplicate acknowledgement. If you see both acknowledgement is one, it's a duplicate acknowledgement. Wireshark says it's packet number 11 duplicate acknowledgement. And once this successful connection, say since SYNAC ACK, your actual TCP, your actual telnet data is going through after this three-way handshake. And as we discussed, it's a 4 tuple connection: source IP, destination IP, and source port and destination port, 4 values. So I'm done. So my connection established successfully. So what's next? So here exactly I'm trying to use a telnet. My TCP stream is going well and I see acknowledgement back. I send a next set of sequence of data. Here you see the payload is 12 and here the payload is 42 and 42 plus 13 and you get the value here 55. The next sequence number is because I got this and I acknowledge this. I send this, I got this data and I acknowledge this back and I received it. So I see my all this communication happening smoothly. I'm good. So what happened exactly here? Until this point, I pressed and typed some commands and my telnet data is keep happening. At this point, if you actually see 10.0.0.1 is the destination. If you look at the IP details here, show IP interface brief, it's 10.0.0.1. So 10.0.0.1 says hey, we are good. You're done with that. So I'm going to send this fin. Let's close down this connection because you're done. You want to close this connection. So once you close the connection, I'll also close my connection here. This is 10.0.0.2. This is a source where I initiated the traffic. I give show IP interface brief 10.0.0.2. So you also send a fin and I also send a fin. My connection flows smoothly. No TCP errors at all. If you see duplicate acknowledgement, if you see this black packets, 1 or 2, and it depends on the circumstances, as I said, if it is more, and if you're losing more data, then you have to look at this. But at this circumstance, this particular scenario, I have a successful connection. Both send a fin. I'm good. So the takeaway is how I can analyze and how what we should know about how sequence number works, how acknowledgement number works, what is duplicate acknowledgement, what is fin. So all this are vital data you should know about when you do a troubleshooting. So this is a successful connection. I see fin. That's good. So in the same way, how this switch is actually looking at this packet. What is the maximum details I can see from the switch? If I give, if you actually see, this is because I enabled a log and it says the traffic is coming from 10.0.0.2 on port 23 telnet, one packet. Yes. So this particular ACL is for fin. So 5 matches. So this is only information I can see, but in the Wireshark, I can see, okay, what is the acknowledgement number? What is the source number? And where exactly the fin is happening. See, I see all the streams, all this data is successfully exchanged, right? I'm not missing any TCP packets here. You do not see all this in the router, right? So I see the successful communication for all this sequence number. So my data transfer is happening very smoothly and we are closing a connection. This is a gracefully closing the connection without any errors. But this is going to just show you, okay, do I see the fin packet? Yes, only that information. You do not have granular control over all your packets, whatever you see. But in Wireshark, you can see all this details here. And if you go and check here, the selective acknowledgement, as I told, see, this is here in the selective acknowledgement, there is no missing packet, so I don't see anything here. And if you look at here, I see only the window scaling factor, flags. I don't see the options here other than the window scaling factor. So here no window scaling is used because if you look at the actual data, whatever I sent here, it is below 4128. So all are 3 bytes, 2 bytes, 560 bytes. That's the maximum payload I have here. It's not used. So it depends on the circumstances where you use that. And if you click on the left corner here, you can see all these details. So connection fin packets. If you right click, apply as a filter, you see only the fin packet. So from source to destination, I see fin. From destination to source, I see fin packet. So, okay, I got a confidence. Okay, my connection has successfully happened and both close the connection successfully. And I see SYNAC from the server, because the port 23 to the source port, random port. And maximum segment length 1460 and the window size 4128. Do I see duplicate acknowledgement? This is bad. Yes, I see only one duplicate acknowledgement. And this is from the client to the device. From looking at the port number, I know, and this is the window size. and it is using TCP. So this is very helpful. If you want to apply this as a filter, select this and you see only the duplicate acknowledgement. tcp.analysis.duplicate.acknowledgement. So you cannot remember all this filter, but you can make use of this Wireshark export information. From that, you can make your own filters like this. You can right click, select, and it will be applied as a filter. So now let's see how retransmission happens. For that, let me go back here. So now let me stop the capture. Stop capture. So go back to router 1. Let me configure. Let's initiate a TCP connection again. Start capture. Okay. So I short loads. It fired up, so I can see packets going on. So let me go back to R1 telnet 10.0.0.1. Let me press up arrow. I'll get telnet 10.0.0.1. So I give the password, enable, again password. I'm on the prompt. So the traffic is still going on. You do not see any fin packet because I didn't finish the connection. So apparently I should not see fin packet now. Now let's go to this device. Show IP interface. Let me do it here. Show IP interface brief. Configure. And I'm going to shut down this port. So now shut down. And let's see what's happening here. So I lost access to it. And if you see here, 10.0.0.2, my source router keeps sending retransmissions. Hey server, you're not receiving my data. I'm keep sending the packet back again and again. I'm sending retransmissions. This amount of data it sends, 6 bytes, and keep sending retransmissions. So if I go back to switch 1 and if I give no shutdown, exit, exit. So now I should not see any more retransmission happening here. If you see who is sending a retransmission, that is important. So my source 10.0.0.2, my router is retransmitting to this destination Ethernet switch. Sorry for that. This is my Ethernet switch. So now I know, okay, I'm sending a retransmission. The destination is not responding back, so I keep sending a retransmission again and again and again. So once this is done, I get an acknowledgement back. Again, my telnet data is sent from source to destination, destination to source. So this is how the retransmission works in real time. And when you see retransmission, you should see where exactly the retransmission is happening, who is retransmitting the data. So that is important here. So that's it about TCP retransmissions. And we saw what is resets and what is fin, and we did a lab for it. And we discussed about how to apply the filter for reset, how this is a filter for fin packets. And now we'll see a use case for there is a problem with the client. So I mean, there is a scenario where we have a problem and we are going to find, is it a problem with the client or it's a problem with the server? This is a use case. So I'll open up a Wireshark for it. Okay, let me close this. So the very first thing is I have to go to the expert info here. So I see, I mean, this is really huge out of order. So I'll tell you. So this is very important. I'll go back to this paint. Let me delete this. This is source and destination, and I'm just making this synac ack. The source. This is destination. So the key parameters we should look at. Let me show you this. Let me take this. So TCP retransmission. TCP retransmission, out of order packets, duplicate acknowledgement. This all proves we have a problem with network. But as I told you, it depends on the circumstance. If I see that in the minimal, that's okay, that's because of a latency. There is a device in the middle or maybe a destination is not processing the data and it has a link issue because the link got choked up. But if there is a continuous retransmission, if you see a lot of out of order packets and duplicate acknowledgement, then definitely it's a network issue. Then based on the circumstances, you have to figure out, as we looked at the retransmission with the lab analysis, we come to know who is sending a retransmission. So it is because of interface, the IP communication is not happening because the point-to-point connection was down. So it keep retransmitting the data to send it back. So it is a problem with the destination. So based on this, on the circumstances, you have to figure out where exactly the problem is. So, but the biggest takeaway is how we're going to find it. If we know the basics and if we know how it exactly works, you can figure out in any complex network, you can figure out where could be where the problem actually exists. So now coming to this, how I can filter out the bad TCP connections. So if somebody says, okay, so I have some problem, the server is not responding or it's a client not responding, the very first call I would take is, okay, first let me open the packet capture. Send me a packet capture here. Let's open up the packet capture. Okay, let's see the very first packet, synac ack. So the time value is the key crucial thing when I always look at. So here it takes 3 seconds. takes 3 seconds. After this dotted decimal, the right hand side, it is milliseconds, and if it is the left hand side, it is seconds. We discussed about that. So it takes 3 seconds to send a SYN. Some Dropbox communication is happening, and here exactly the TCP communication happens, and all goes well here. And this is based looking at this protocol SMB. This is a file share. You can see that this is a shared folder. It's trying to access, and it is trying to copy a file. So I should look at all this. Okay, I established a TCP connection. So what's next? So it's my file share. So I'm trying to download some file. It's a file transfer happened between source and destination, and this is a client, and this is a server. And let me drill down here. So if I go for any bad TCP packets, I see duplicate acknowledgement here. Let me apply as a filter, selected. I keep sending this duplicate acknowledgement. So packet number 1024. So let me close this, go to packet number 1024. So after this, exactly, I see this duplicate acknowledgement. It says I already acknowledged this 9042. Can you see this 9042? Already acknowledged this. If you see here, but still I'm sending an acknowledgement because I'm missing out some data here. But here is the main thing. See, if there is a duplicate acknowledgement, the very first thing my eyes always goes to this time filter. If you see the actual communication, the round trip time, RTT, we say RTT from source to destination, destination to source. It's very, very minimal. It's happening in 25 milliseconds. It's happening in 134 milliseconds, 101 milliseconds. It's not even going to seconds. So it's definitely, see, this is all TCP duplicate acknowledgement. The client is sending back to the server. So what are the other things I have to look at? If you see, there is continuous data, and you have to compare side by side. Is it my time values increasing? No, but the client is keep sending the duplicate acknowledgement again and again because I didn't receive this packet. And if you drill down, I see the client is keep sending a duplicate acknowledgements. I keep sending a duplicate acknowledgement. You have to go through the complete capture. So let's see the FIN packet. If I see the FIN packet, the connection establishment is fine. TCP.flags.fin equals 1. If it is true, it should show me the FIN packet. So it says the displayed value, no FIN packet here. So the communication is broken in the middle. The complete communication is not happening, and the client keeps sending this duplicate acknowledgements. I am not receiving your data. So if you see the out of order packet, duplicate acknowledgement packet. As I told, this all interrelated. So if you see a lot of duplicate acknowledgement, a lot of TCP out of order, but there is no problem in the network. It is something problem with the application. It is because of the server or this particular application 10.0.0.2 has a problem. It has a problem. So we have to look at this server, this particular application, why it is not happening. So I am missing a lot of data because of the server, not because of the client, because I see all this black packets. It's keep the client sending back to the server. The server is not sending back anything. So this is a use case. You can make use of it, and you can see the retransmission. So do you see any retransmissions here? TCP.analysis.retransmission. So the server is sending a retransmission. Again, if I follow this filter, conversation filter TCP, duplicate acknowledgement, and for the missing packet, the server is sending back again, but not a lot of retransmission. That is important. So I see hardly one or two retransmission from the server, but from the client, I see a lot of duplicate acknowledgement, a lot of TCP out of order. So what exactly the out of order says? See, I'm missing out some data in the middle. The segment, whatever I'm receiving, I'm missing in the middle. As I told, I got a check of, I got, the sequence number, acknowledgement number, and my TCP stream is happening very well. But in the middle of something, I'm losing a packet between 1056012 and 1057472. So definitely this is a problem with a server. And the very first thing when you look at the network issues, you have always look at this time value. Is it my round trip time? Because see, from source to destination, destination to source, how long it takes. This is my source and this is my destination. And what is the time taken here to send and receive? Round trip from source to destination, from destination to source. It looks good. I do not see any problem here. So I'll give you one more use case for a retransmission. So example, I got a device like this. I got a switch. So I got two devices connected like this. This is a use case where I experienced a problem with, and this is a voice device, voice gateway. And this is a Nexus switch, 7K. And we got a connection like this. So this is a firewall. And this is a firewall. And this is a Cisco device. And this is a Palo Alto. So example here. So the layer 3 is on both device. So let's take a segment 167.0.0.1/8. Let's make this as 167.0.0/24. So I got this. So 8, it means the first octet, the first pot. And here, so it matches on both. So this particular SPC has been assigned, sorry, this voice gateway has been assigned with 167.0.0.05/8. The communication between the switch and the firewall is just a layer 2. Both use the same VLAN. Example, VLAN 800. Here also I'm using VLAN 800. So from the switch perspective, is one layer. It's only a layer 2. This particular SPC is configured with VLAN 800 access port. And on this particular interface, I assigned this IP address, this voice gateway. So when we had a problem, when we did a capture on this voice gateway, and we see a lot of TCP retransmissions. from 167.0.0.5 is sending a lot of retransmissions. To a public IP. Example, let's take, let me take this 8888. So what is the real problem here? So the traffic coming from this switch, it has to go to this firewall, and this is an outside interface. And it has to go to the internet. A lot of retransmission is happening, but when we looked at exactly the retransmission packet, example, this is not a retransmission packet. So when I exactly look at the retransmission, if I go to retransmission, in the layer 2, I do see here this particular destination MAC address, it was showing for Palo Alto. But it is supposed to be an ASA Cisco firewall. So from the SBC capture, we found, okay, the traffic is actually, it is destined for ASA. Actually, it is destined for ASA. It has to go this path, but instead it's going through this. This is correct. So it is going here. But the actual path, it has to go through this path. So only with the layer 2 header in the retransmitted packet, the layer 2 header, you can see that. So my heart suggestion is you have to look at in every field, and you have to compare. You cannot just compare with retransmission. You can figure out, okay, this is the problem with the source and destination. You have to go through everything, every possible base, and it is based on the circumstances. You have to apply the logic, and we have to figure out. So this is about TCP retransmission and the use cases we discussed. And when you actually see this black package, it's really a bad TCP. And the filter, you should always use, the very best filter is TCP.analysis flag. Along with that, you can also use Wireshark expert info. Both gives the same output. You can see all your bad TCP. TCP.analysis.flag, very useful filter. And if you want to apply this particular filter, you can add, and you can apply this as a filter, your own filter. If you want to make it as bad TCP. So whenever I look at any packets, if I just click on bad TCP, it's going to show up this. This is how you can apply your own filters. So you can do your own capture, and you can try to answer these questions with your own capture, so you'll understand. And if you have any questions on that, you can ask me. So let me put this in the chat for everyone. Okay, I'll put this the chat. So the final the final thing we'll discuss about the use case for a trace route. I found this is quite interesting. So I want to share this. And if we discussed about all this time to leave exceed and how TTL works. But here from source to destination, what is the number of hops? So if I try to make it with 4 hops, I'm not reaching the destination. If I make it with a 5 hops, I can reach the destination. You can see all this TTL is 5 hops. So if somebody asks a question and somebody you have any problem with your latency, and you can very well, you can concretely you can say, okay, I am 5 hops away from this source to destination. There's 5 hops. The very end of this packet, you can see that information. I found this is useful. And if you look at this, it uses UDP. It can be a Linux box. It can be a Cisco device. So the main key thing here is what we have to look at here. So from my source to destination is 5 hops. And if you do same PCAP on this destination 172.16.0.2, you'll get to know how many hops away is 10.0.0, 10.0.1.2. So how many hops away is my destination? So this is all about for today's class. This is a capture we are taken from this MPLS connection and to find the number of hops. If there is a question, so how to find the number of hops from source to destination in the end of the packet, you can see here the number of hops is 5.